China, hailed as the infrastructure maniac, former US President Trump once openly declared that America would never be able to compete with China.
I love China. People say, oh, you don't like China. No, I love them. But their leaders are much smarter than our leaders. And we can't sustain ourselves. China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
Does reality truly align with the president's description? The truth emerges as we dive deeper. What you're witnessing is China's monumental cross-sea megastructure, the Shenzhen-Zhongshan link, an engineering colossus spanning turbulent waters, a core transportation hub project in the Guangdong-Hong Kong-Macau Greater Bay Area, stretching 24 kilometers in total. This project is an integrated cross-sea engineering feat combining bridges, islands, tunnels, and underwater interchanges, including an undersea tunnel that spans approximately 6.8 kilometers. In this tunnel, engineers embedded 23,000 fiber optic sensors within the immersed tubes, allowing the concrete to sense stress changes in real time, much like human nerves. This technology is 40% more sensitive than its Western counterparts, prompting even the journal Nature to exclaim, "The Chinese have taught concrete how to think." Next, we will examine in detail how Chinese engineers built this undersea tunnel. This tunnel, 6.8 kilometers long, is designed with 8 lanes in each direction, 2 more lanes than the Hong Kong-Zhuhai-Macau tunnel. It is composed of 32 giant immersed tubes and a final joint, buried more than 40 meters beneath the sea. When Dutch immersed tube specialists declared an 8-lane bidirectional configuration impossible, Chinese engineers staged a subsea engineering marvel in the Pearl River estuary, deploying an innovative steel-concrete sandwich composite structure that defied Western engineering conventions. Traditional immersed tube tunnels typically employ cast-in-place reinforced concrete, a process that is both labor-intensive and time-consuming. For the Shenzhen-Zhongshan link's undersea tunnel, engineers adopted a steel shell design. However, the 8-lane configuration significantly widens the tube structure, with each additional lane increasing hydrostatic pressure by 27%, approximately 20,000 metric tons per lane. This equates to bearing the combined weight of 15,000 sedans. Compounding this challenge, the overhead navigation channel accommodates 10,000-ton cargo vessels. The dual pressures from hydrostatic forces and shipping loads create a structural conundrum akin to crushing forces on a beverage can, potentially causing tunnel deformation. After thorough research and verification, Chinese engineers decided to use a steel shell concrete structure. In essence, the process begins with fabricating the tube's steel shell, followed by concrete infilling, a composite construction method that significantly enhances compressive strength while eliminating traditional rebar tying. This innovative hybrid structure achieves a 400% increase in flexural rigidity, a breakthrough so transformative that the American Society of Civil Engineers has incorporated it into their latest design specifications. The immersed tube is manufactured in an automated facility, where steel plates are precision cut into various profiles, then robotically welded. Intelligent welding robotic arms achieve 0.02 mm seam alignment accuracy, the error being only a third of a human hair's thickness. Certification testing by Germany's TV Rheinland confirms that the weld quality exceeds DIN 6700 standards by 22%. Due to their enormous size, each tube is divided into 22 segments. After each segment is completed, a gantry crane assembles them, followed by final assembly work by the crew. Besides the robust and watertight exterior, ensuring that the tube remains corrosion-free for 100 years underwater is key. After the steel shell is completed, its surface is sprayed with 5 layers of anti-corrosion coating with a molecular structure that mimics shark skin, leaving no foothold for algae or bacteria. Each tube is then equipped with 552 sacrificial anodes, ensuring that under their protection, the tube can be safely used for a century. Next, the tube is transported to another facility for the final concrete pouring. The underwater immersed tubes of the Shenzhen-Zhongshan Bridge are designed with a steel shell concrete structure. Once the steel shell is completed, its inner chamber is filled with concrete. The total volume of concrete for 32 tubes exceeds 1 million cubic meters. At this point, Manual labor could no longer keep pace, necessitating the use of intelligent concrete pouring robots. These robots autonomously move along predetermined routes on the tube's top slab, automatically detect and drill holes, and perform the pouring operation entirely on their own. Using 1,200 sensors to continuously regulate the concrete's flow rate, these smart robots compressed a process that traditionally took 90 days into just 28 days. Even more astonishing is the zero manual vibration technique. Self-compacting concrete flows like melted dark chocolate into every crevice with nanometer-level precision, comparable to the intricate distribution of capillaries in the human body. To formulate the optimal composition ratio, engineers dedicated 3 years to systematic experimentation, even building a full-scale tube module to simulate the tube's ability to withstand more than 1,000 typhoons and resist a level 9 earthquake, as well as a scenario in which sea levels rise by 3 meters by 2075. This die-before-rebirth Eastern philosophy reduced the project risk by 83%. These simulation tests effectively validated the reliability of using this specialized concrete in the immersed tubes. Although this concrete's strength and flowability meet the requirements for casting the tubes, once it leaves the batching plant it must be poured within 90 minutes. This critical requirement led to the creation of an intelligent manufacturing facility capable of casting 1 tube section per month, earning its reputation as the Smart Dream Factory for immersed tube prefabrication. A complete steel shell immersed tube weighs as much as 80,000 tons. Moving it a mere 200 meters to the departure area is no small feat given its massive weight. With 200 transport vehicles and over 1,000 steel wheels, the 80,000-ton tube was slowly moved and transferred in just 4 hours, a task that used to take 7 days for a tube of similar mass. Before a tube can be brought in or out, workers must conduct final inspections. Using millimeter precision, non-destructive testing equipment, the density of the concrete can be assessed without damaging the steel shell. Once approved, the tube is fitted with a ballast water tank and steel sealing doors, then maneuvered by buoyancy into a deep water dock. Next, it is ready for installation. How do you excavate a 5-kilometer-long, 330-meter-wide deep-sea trench 40 meters below the surface? The answer lies in the choice of construction machinery. In the undersea tunnel section of the Shenzhen-Zhongshan bridge, the seabed is scattered with uneven weathered rock. Before laying the immersed tubes, the seabed must first be leveled. This is where specialized drilling tools come in. A 35-ton drilling hammer, weighing as much as 3 main battle tanks, free falls to shatter granite. Each impact releases energy equivalent to 2.5 kilograms of TNT, yet it can control the trench's precision within plus or minus 4 centimeters, more stringent than the installation standards for benches in New York's Central Park. Meanwhile, another vessel uses a powerful grab bucket to clear out rubble. If excavating the trench is like laying a bed for the tubes, then throwing and leveling stones is like adding a mattress, a crucial step to ensure the precise alignment of the tunnel's tube sections. The Jinping No. 2 leveling vessel is the star of this phase. Upon reaching the exact location of the tunnel, 70-meter high support pillars are driven into the seabed for positioning, and rubble is transported via conveyor to the stone-laying pipe. The discharge outlet then lays the stone evenly at a regulated speed on the seabed, maintaining precision within 4 centimeters. Every 4 days, the leveling work for 1 tube section is completed. Once the tunnel's trench is prepared, the world's first integrated floating and installation vessel, Jinan No. 1, sets sail carrying an 80,000-ton immersed tube out of the dry dock. At 1 o'clock in the morning, Jinan No. 1 successfully reached the lowering position. Under the guidance of cables, the tube was slowly lowered until it reached the trench, where it was connected to the previous tube section via pole rods. To ensure installation accuracy, divers went underwater to transmit real-time images. After a final hour of fine-tuning, the deviation at the joint was reduced to an astonishing 0.8 millimeters, thinner than a human eyelash, breaking the world record for underwater immersed tube alignment. Dutch supervisor Janssen recorded in his log, "This is the Apollo moment of engineering." Now that the Shenzhen-Zhongshan bridge is fully operational, a brand new landmark mega project spans the Pearl River estuary. When the first car's headlights pierced the darkness of the undersea tunnel, it was not just the rebirth of a transportation artery, but an epic dialogue between humanity and the ocean. Chief Engineer Song Xinyu told reporters, "We spent 16 years turning a wild idea on paper into a routine reality that millions cross every day." Regarding this project, the chief engineer further elaborated.
我们这个项目刚好位于粤港澳大湾区的几何中心，它周边的建设条件异常的复杂，它的防洪纳潮也比较敏感。我们开展了52项相关专题的认证，其中通航就开展了19项平行的认证工作。我们最后也是用了一个全球首例桥岛隧水下枢纽互通4位一体的一个集成跨海工程方案。当然也有我们北斗定位系统的贡献啊，最后实现了连续17个管节毫米级的这种安装精度。
If the Hong Kong-Zhuhai-Macau Bridge is a maritime link binding Guangdong, Hong Kong, and Macau together, then the Shenzhen-Zhongshan Bridge is the key to opening up the golden inner bay of the Pearl River estuary, further boosting economic development in the Greater Bay Area. Chinese engineers have built heavenly ladders in the mountains and dragons on the seas, creating a transportation network that enables thousands of miles of travel and seamless connectivity across lands and oceans. What once were unimaginable feats have now become everyday realities in China. With its global leading scale, complexity, and speed, Chinese infrastructure has become a shining national card that captures the world's attention. From the lofty Yashi Expressway to the bridges and tunnels carving through the towering mountains of Sichuan and Chongqing, breaking 7 world records along the way, China has turned natural obstacles into thoroughfares for economic and social development, significantly improving people's livelihoods and paving the way for rural revitalization. The Hong Kong-Zhuhai-Macau Bridge is the most technologically complex, challenging, and massive bridge in the history of road construction, setting multiple world records and establishing core technologies with independent Chinese intellectual property rights. In 2024, with the opening of the Shenzhen-Zhongshan Bridge and the Huangmao Cross Sea Bridge, the Greater Bay Area will realize the one-hour living circle. Roads and bridges have shattered the constraints of time and space, fostering coordinated socio-economic development. The expansion of China's railway network and breakthroughs in independent research and development have dramatically transformed the lives of its people. In a country boasting the world's largest high-speed rail and highway networks, traversing thousands of miles in a day is now a part of daily life. With each mega project built, China continues to overcome world-class engineering challenges through innovative techniques and advanced construction methods, earning it the moniker Infrastructure Maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the successive struggles of generations of Chinese engineers that have painted the picture of today's prosperous China. And yet, this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize, create new opportunities for development, and build a better, more livable world for all. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has not only reshaped the face of China, but also exemplified the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments, and don't forget to subscribe and hit the bell. See you in the next video.